everyone, I'm Sandra Fott. I'm the manager of NSDF Regulatory Approvals, and one of the best parts of my job is to be able to get out in the field and show people the NSDF site. With COVID-19, we haven't been able to get people out, so Mike is with me today, and we're going to take you guys on a virtual tour of the NSDF. So right now we're standing just inside the gates of the Chalk River Labs. You might hear a little bit of traffic and backup beeps going on. There's a little bit of construction around us. But the Chalk River Labs itself is about 4,000 hectares. A lot of it is forested, like you see behind me. The NSDF site will be about 37 hectares of our 4,000. There's about 3,000 employees that work at the Chalk River Labs. So every day we've got engineers, we've got skilled trades, we've got administrative staff, all kinds of people coming here to work at the lab. And we're super proud of it, and we're super happy to be able to show you the project site today. All right, so Mike and I are making our way down Plant Road. It is about 9 kilometers from the Chalk River Gate to the Chalk River Labs site, and I'd say we're about halfway down right now. Along the way, we saw 2 wild turkeys along the side of the road. The Chalk River site has lots of wildlife and approximately 21 different species at risk. So today we've invited one of our environmental specialists, Annie Morin, to talk a little bit about the turtle culverts that we've put in, or as I call it, the Turtle Highway. So Annie's going to come in and explain a little bit what the culverts are for and some other work that we're doing here to protect species at risk.
Merci beaucoup, Sandra. Donc, comme Sandra le mentionnait, au site de Chalk River, nous avons environ une vingtaine d'espèces en péril, dont la tortue mouchetée. La petite population de tortues mouchetées au site de Chalk River est menacée par la densité de trafic que l'on a sur notre route principale. Donc, c'est pour cette raison qu'on a décidé cette année de créer des passages pour la tortue mouchetée, mais aussi toutes les espèces de tortues. Donc, nos passages à tortues incluent comme un grand passage avec beaucoup de lumière, un tunnel avec un système de clôture pour amener les tortues à passer au travers de la calvette. Donc, en créant ces passages à tortues, on espère éliminer la mortalité sur les routes pour la tortue mouchetée, mais aussi toutes les espèces de tortues. Dans le cadre du projet de gestion des déchets près de la surface, puisqu'il va y avoir une augmentation du trafic, on espère aussi éliminer encore plus ou éliminer complètement la mortalité des tortues sur les routes en créant 4 autres passages comme celui-ci sur le site de Chalk River. Comme ça, les tortues vont pouvoir utiliser les passages au lieu de traverser pour aller à leurs différents habitats en utilisant la route. Aussi, pendant le projet de gestion des déchets près de la surface, on a aussi des mesures d'atténuation qui sont spécifiques au projet, qui incluent des barrières physiques et aussi des restrictions au niveau du temps de l'année auquel certaines opérations peuvent être entreprises. Et on a aussi des inventaires ou de la surveillance qui va se faire à tous les jours pour s'assurer que les tortues ne sont pas sur le site de construction.
All right, so Mike and I have continued to make our way down Plant Road, and right now we're about 1 kilometer from the main Chalk River site. And right where we're standing behind us is Waste Management Area A. Waste Management Area A is Canada's first nuclear waste management area. So this site was opened in about 1945, 1946, and waste continued to be placed in this area until about 1981. In Waste Management Area A, they mainly use sand trenches, so not a lot of containment from the environment. Beside us is the liquid dispersal area, and sort of the same thing. Waste that went into the liquid dispersal area was put into the sand trenches. 90% of the waste that's proposed to go into the NSDF is here on the Chalk River site, and these 2 areas are examples of waste that, should the project be approved, we would be able to get away from being in these sand trenches and put into containment in the NSDF. So there are a number of groundwater monitoring wells that are behind me, and the groundwater monitoring wells were actually installed back in the 1950s. So the Chalk River Laboratories is actually known as the birthplace of contaminant hydrology. So as we'll hear more from Annie later about all of the environmental monitoring that happens on the Chalk River site, but we have groundwater data from this area in the Perch Lake Basin since the 1950s. So the groundwater movement in the Perch Lake Basin, where the NSDF site is well understood. All right, so now we're at the boundary of the NSDF project site. Just behind me is the plant road, so it's not too far off of Plant Road that the project site will be. When siting for the NSDF, we actually looked at 15 different sites on the Chalk River Lab site. These sites were looked at with mandatory criteria, such as we needed a minimum amount of space, we needed access to power and other services. So from that mandatory criteria, then we also had exclusion criteria. So some of the exclusion criteria would be the presence of species at risk, whether or not the project site was in a floodplain, and we looked at geotechnical considerations. So once we looked at the mandatory and exclusion criteria, 2 sites were evaluated further for the NSDF. So of the 2 sites, both were technically feasible, but the chosen site, which is on East Mattawa Road, which is what we're standing on right now, was preferred because this area is within the Perch Lake Basin, so it has been historically impacted by other waste management areas, as well as I explained earlier, the Perch Lake Basin has been monitored since the 1950s, so within this area, the groundwater, the surface water, everything is very well understood. The alternative site, which is in the Chalk Lake Basin, is in a non-impacted area, and it actually, even though it looks on a map that it's further away from the Ottawa River, the drainage time from the Chalk Lake Basin to the Ottawa River is shorter than what we have in the Perch Lake Basin. So what we're going to see when we climb the hill here in a few minutes is a groundwater ridge divide that's on top of the NSDF project site, and we'll be able to see a little bit better how the groundwater is going to move away from the river. All right, so Mike and I have made our way up the ridge, and so we're now standing at the top, and I'm going to use my notes a little bit because I have a lot to say up here. So behind me is the Ottawa River, and we are about 1.2 kilometers to the river as the crow flies. Behind Mike is the village of Chalk River, and it's a little bit hazy, but from here you can see the water tower, which is probably about 10 kilometers from here. One of the things when we were siting for NSDF was that we did not want the NSDF project site to be visible from either the village of Chalk River or from the Ottawa River. So this ridge actually will provide a little bit of a shield from any visibility to the project site. We are currently at about 193 meters above sea level, and the Ottawa River is typically at about 115 meters above sea level. For the floodplain studies that we've done, we've used 123 meters above sea level kind of as the maximum flood scenario that we might see, and that is breakage of 3 dams upstream of the Chalk River site. So we are well above any worst case scenario for flooding. So we are at a high point, but even at the low point of the engineered containment mound, we're still at about 150 meters above sea level. We do have a bat box up here, and Annie's going to talk a little bit more about bats when we head down to Perch Lake in a few minutes. So I won't touch much on that, but the bat box up here on the ridge is currently being occupied by 3 different species of bats that we have at the site. Just over to the right will be where the wastewater treatment plant is going to be constructed. So the wastewater treatment plant will treat leachate that's collected from the engineered containment mound, as well as any leachate that comes off of the decontamination facilities. There's going to be an exfiltration gallery where the discharge from the wastewater treatment plant goes. All discharge, all effluent will be tested prior to discharge to make sure that it meets effluent discharge targets. If it doesn't meet those targets, it will be recirculated back through the plant until those targets are met. In the case of any high water tables with the exfiltration gallery, we are going to have a backup discharge pipe to direct discharge to the Perch Lake. We are currently working with Ducks Unlimited and looking at using different components of artificial wetlands in our design around the exfiltration gallery. So that's just another way that we can enhance water quality from the discharge of the water treatment plant. We are on a groundwater divide here, so it's not really intuitive, but sort of behind me, water does flow down towards the river. But the NSDF project site is behind Mike, so behind the camera. And water from here flows downhill towards Perch Lake and Perch Creek. So it isn't really intuitive that on a map we look so close to the Ottawa River, yet the groundwater and water flows in the opposite direction. What's important about that is we know from our groundwater modeling studies that the transit time from this area to Perch Creek is somewhere between 7 and 12 years. So in the very unlikely event that there was any issues with groundwater detected through the monitoring program, we would have lots of time to come up with mitigation measures to stop any potential releases off the Chalk River site. We are on bedrock up here, so there will be some blasting that needs to be done. And we will be using the rock that we blast from this area to construct the engineered containment mound. From up here, gravity, the effluent discharge will flow by gravity down to the Perch Lake. And the engineered containment mound will have to pump leachate up into the water treatment plant. We've installed about 30 new groundwater monitoring wells up on this ridge. So again, we have lots of good baseline data. This was done to look at bedrock characteristics as well as groundwater. So we are continuing to monitor these wells for groundwater quality, but this area up here is currently unaffected. So Mike and I are going to head back down the hill now, and we're going to meet up with Annie at Perch Lake to talk a little bit about the CNL Environmental Monitoring Program, about the bats, and about biodiversity in Perch Lake.
As mentioned by Sandra, we are now on the site of Perch Lake. So Perch Lake is located south of the proposed boundary of the near-surface disposal facility. So we have conducted several surveys in the lake and around the lake, and a fish survey conducted a few years ago demonstrates that the fish community is fairly diverse in the lake. And an interesting fact is that the survey we conducted a few years ago, the species composition is also very similar to a fish survey conducted in 1980 by the Waterloo University. This lake also hosts several turtle species, such as the painted turtle and the snapping turtle. And we are currently at the outlet of Perch Lake, so Perch Lake is flowing into Perch Creek. So this location is also a very important location as part of the environmental monitoring program of the Chalk River site. So the Chalk River Environmental Monitoring Program has been ongoing for over 60 years. We collect about over 5,000 effluent samples every year, conduct over 20,000 analyses every year, and this location is part of this program. So it is a very important location because Perch Creek will then flow into the Ottawa River, so we do have one additional monitoring station before the water is released to the Ottawa River. We do monitor for a suite of contaminants, radionuclides and other contaminants such as mercury or lead, and the monitoring program followed the N288.4 standard, CSA standard. At this location as well, we do have a bat box, or a couple of bat boxes. So as part of the NSDF project, we have installed in 8 different locations 16 bat boxes. So every location has 2 bat boxes back to back, and the locations are all in the outside of the proposed boundary of the near surface disposal facility. So the bad boxes were installed in 2017. First occupancy was detected in 2018 with just a few bats using the bad boxes. And as of last year in 2019, really the occupancy went up in the bad boxes. So we have installed the bad boxes very early on because we wanted to make sure that there was an overlap with the bad boxes if the NSDF project was going forward and the bat habitat removal that the NSDF project would cause if it goes forward. So the bad boxes, as the years go by, so this year, for example, we do have bad boxes with an occupancy of over 40 bats, and a bad box can have over 300 bugs. We were able to confirm that the bad boxes were used as a maternity ruse because we confirmed that there is non-violent individual in the box. We are also engaged with Trent University with the telemetry project on the bat at Chalk River. So bats that were captured last year and tracked, their movement were tracked for several days, confirmed that a bat can use a bad box and a natural environment interchangeably. So this information is very interesting because we will be able to take the movement pattern of the bats and habitat preference, and we will feed this into a sustainable forest management plan that we are currently developing with the Canadian Forest Service for the Chalk River site. So by engaging or by producing a sustainable forest management plan for the site, we are hoping, well, the goal is to make sure that we maintain or enhance wildlife habitat on the Chalk River property, including habitat for the bat species at risk that are present here at the Chalk River site.
So we've stopped now at a test pit that has been left exposed from the archaeological assessment that we did as part of the NSDF project environmental assessment. The archaeological assessment was done in 4 stages, with the three stages were actual field work. And throughout that field work they did 10,000 test pits similar to what you see behind me and recovered about 5,000 different artifacts. Those artifacts were small tools and stone scatters. So it was evidence that there were small campsites or workshops and quarries in this area. But overall, the conclusion of the archaeological assessment was that there was nothing of cultural significance found within the NSDF project site footprint, and no further archaeological work is recommended. So now we're at a dust monitoring station. So behind me are high volume air samplers. We installed these air sampling stations a couple years ago, so we've been collecting baseline data and are continuing to do that this summer as well. These are part of the environmental protection plan for the NSDF project. There's 2 sets of them. This is the downstream location, and there's another one which is considered upstream on the plant road side of the project site. When we are operating the NSDF project during construction and operation, there will be mitigation measures in place to control dust. So these are verification that our mitigation measures are being effective. The air sampling equipment has filters inside it, so we do measure for radiologicals and non-radiologicals at a third-party laboratory for accuracy. So we're at the end of the tour now, and Mike and I are at Point aux Baptêmes. Point aux Baptêmes is a publicly accessible beach along the Ottawa River. So many families like to come here, park their boat, swim, have a picnic, and enjoy the day here. As employees of the Chalk River site, protection of the Ottawa River is very important to us because we do live here, we play here, we drink water out of the river, and we fish. CNL has, as Annie has mentioned, a very robust environmental monitoring program which does include the Ottawa River and will include the Ottawa River going forward with the NSDF project. All results from our environmental monitoring program are publicly available on the CNL website. You will see behind me the Chalk River Lab main site, and just to the right is the outlet of Perch Creek. So I really want to thank you for taking part in this tour today. Like I said, this is one of the best parts of my job, and it's really unfortunate that you can't be here. It is absolutely a stunning day to be here in the Ottawa Valley. Before we go, I just want Mike to come in so that you guys know I haven't been talking to myself this whole time. So thank you again, everyone, and I'm going to hook up with Megan now, and we're going to take any questions that you might have about the project. Have a great day.